Hi, Ms. Hedgecock here. Welcome to your second video for lesson 1.1, which is all about characteristics of polynomials. We're going to talk about characteristics given a graph. So in the last video, if you remember, we talked about characteristics given an equation. So I would give you an equation and you would be able to find the degree and the end behavior. Those are the two really important things. In this video, we're going to talk about if I give you a graph, can you identify degree, end behavior, sign of the leading coefficient, all of those things. Before we get into that, we need to talk about some vocab. Our vocab word for this lesson is multiplicity. So it's the number of times a given root is a zero. So we're going to talk about this one over here on the left first. Over here is a quadratic. So that means it has a degree of 2. And if you remember, that means it has 2 roots. Roots are where we cross the x-axis. So if we have two unique real roots, we're going to cross the x-axis twice. So we have two solutions, one at x equals 0, one at x equals 2. All right, two unique numbers, but still two numbers. Then we have one unique real solution. So this is still a quadratic. So there should still be 2 roots. However, I only touch the x-axis. I don't go through it. So it looks like I only have one root. I really have one unique real root. What that means is x equals 1 is my answer, but I have it twice. Now, if you put it once, I'm okay with that. But what I would write is I would write x equals 1 mult 2. That means I have it twice. Then over here on our third one, that's not a quadratic, but this is an example of one unique real solution 3 times. So this is actually a cubic. It looks like this. That's the actual graph we're looking at here. I should have 3 roots, but again, I look like I only touch it once. I go through it this time like I did over here. I go through, but this one looks like it kind of gets flat, right? It levels out a little bit and then goes back, where it switches from concave down to concave up. That is, I have 3 times. I have that one 3 times. So I have x equals 0 with a multiplicity, mult 3. Over here, I had x equals 0 with a mult 1, and same with the x equals 2, mult 1. Over here, I call this the bounce. This had a mult of 2. Someone says juke, like you juke someone out. That's a multiplicity of 3. And then our last one is over here. So this is a quadratic, but the quadratic doesn't cross the x-axis at all. If the quadratic does not cross the x-axis at all, it goes down and back up, but never crosses, you have 0 real roots and you have 2 imaginary. So that means I would have to use the quadratic formula and I would get something that says like 2 plus or minus the square root. Oh, sorry. Let me retype that. I would get something that's an imaginary number. So I'd get something like 2 plus or minus I root 5 over 8. That's an example of what I could get with something like that. So 2 still, because it's still a quadratic. So I have to have 2 answers. That's why it's plus or minus in our formula. All right. So we're going to go ahead and do 2 examples. I'm going to run through this one, and then you're going to do the next one, and I'll just put the answers up. All right, so here's our example. Let's start with degree. All right, now looking at it, it looks like it's going to be an even degree because both of my arrows are pointing up. And if you remember, our evens always mimic each other. All right, sorry about that. It's going to mimic depending on your degree. If it's even, it's either going to look like that for end behavior or upside down. All right, so it has to be even, but how do we figure out what it is? So when you get a problem like this, I actually wouldn't start with degree. I would start with something like roots and multiplicity. All right, sorry my screen's all messed up. But roots and multiplicity, all right? So what we're going to do is we're going to look where we cross the x-axis. We're going to identify our real roots, and we're going to say how many times we have those real roots. All right, so here I cross the x-axis. I touch it here, I cross it here, and I cross it here. So it looks like I have 3 roots, but remember, this looks even because of the end behavior. So really, I should probably have an even number. So let's go through them. I'm going to start with 1. So we have x equals 1. We go through it at 1. We go through the x-axis at 1, so it's a multiplicity of 1. Then we have 1 at negative 1. We cross through, so it's also a multiplicity of 1. But over here at negative 2, we bounce. We go boop, boop, bounce. So at negative 2, we have a multiplicity of 2. So if we count 1, 2, 3, 4, we should have a degree of 4. So that is our degree. Now, when we're doing these, we should also look at if we have any time where our quadratic looks, I'm going to draw a picture over here, like if it went like this, boom, 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 all right? So it looks like we have one root, but right here, we would have imaginary solutions because we go from increasing to decreasing back to increasing without ever crossing the x-axis once. All right, well, we're not really going to get into that right now. Oh, erase, erase. Okay, let's keep going. What else? Let's do number of turning points. I think that's pretty easy to do now. So we have 1 turning point. I switch from decreasing to increasing. 2, increasing to decreasing. 3. All right, so I have 3 turning points. The maximum I could have is 3 because my degree is 4. All right, if you remember from our first video. All right, sign of the leading coefficient. To determine the sign, you look at your arrows. I always look at the right arrow. The right arrow tells me. If it's pointing up, it's positive. If the right arrow is pointing down, it's negative. Any single time, doesn't matter what type of degree it is, even odd. All right, so sign is going to be positive. All right. Total number of solutions. If you remember, the total number of solutions should match your degree. So we have 4 total. I'm going to come over here to count how many real I have. I have 1 here. I have another one here, and I have another 2 here. So that's 4 real. Since I have 4 real, and I can only have a total of 4, that means I have 0 imaginary. If I had 2 real, then I would have 2 imaginary. All right? And then domain, range, and all of those are the same as before. So domain, we go all the way from the left, all the way to the right. So that's negative infinity to infinity. For range, we go bottom to top. So I start here at negative 4.848, and I go to infinity. I put a bracket there because it's an included point. Increasing. Increasing, it looks like I have 1 interval, 2 intervals. So I'm going to have to write those. So that means I'm from negative 2 to, oh my gosh, we're going to estimate 1.25, sure. And then from, it actually tells us, 0.366 to infinity. That's my other increasing. And then for decreasing, I have 1 here and I have 1 here. So I'm decreasing from negative infinity to negative 2. And then from, we said, negative 1.25 to 0.366, all right? And those are my characteristics. Some of them, we can do a lot of our other ones like concavity, extrema, end behavior, and I want you to keep those in mind, but these were the ones that were on our screen, all right? So I want you to try this example. I am going to, oh, I put all of them. I'm going to go ahead and pause it myself and do the problem and then just show you the answer. All right, and then there's the example. So this one's a little tricky, I will admit. So the degree is 3, which means there's a total number of 3 solutions. Why is the degree 3, right? Right here, we have 1 real solution. X equals 3, multiplicity of 1. Right here, we switch from decreasing to increasing, back to decreasing, and we never ever cross that x-axis. This little divot right here tells me I have imaginary solutions. Now, imaginary solutions come in pairs, so that means I have 2, all right? And then that makes sense because if I should have a total of 3 solutions, I should have 1 real, 2 imaginary, all right? It is negative leading coefficient because down here, points down. End behavior, domain, range, all of that we've done before. Relative mins and maxes, if you can't really see, it's approximately 5 and 2 for your relative min and max, all right? But that's it for this video. So your next step is you're going to watch the even, odd, or neither video. None of the teachers recorded that, but it's a really good video that we found that we wanted to use instead. Your should do is the characteristics of polynomial worksheet. I would do it. It would be great practice before you do your mastery check, which is your first thing to do. All right, good luck.